Trump won, so they went home. They're scared.
What?
They're scared.
They're scared.
They are scared?
Yeah,
Why?
because they were Clinton supporters.
Sorry, who's supporters?
They were Clinton supporters.
I have no idea what you're talking about.
Hillary Clinton supporters.
What does that mean?
The other person that ran against Trump.
I have still no idea what that. What? Trump? Clinton? What is he saying? You guys know? It's like living in an alternative universe. Alternate universe.
What's your comment from last night?
I don't know. I slept nicely and last night. What else do you want me to tell you? It's like any other night.
True.
I knew you.
Sorry?
I knew you would do this.
I still have no idea what you guys are talking about. All right. Anybody has anything interesting to say? What? What is that? I'm not. I don't even know what politics is. I'm probably not talking about that. How come you fellows sitting in the back today?
It's evacuation, just in case we start talking about politics.
Oh, okay. I don't know. Why would I ever do something like that? But you can come in the front. No, I'm not talking about politics.
Are you sure?
Yes, I'm sure. You can come in the front too, yeah. I'm going to talk about optimization. All right. I don't know why that's funny. I'm just talking about what I should be talking about in this class. Which is so unusual, so unlike me. Alright, so last class we're talking about true variable optimization. So we're talking about f is a function of x comma y. And finally we derive that the conditions for maximum or minimum are that fx must be 0, fy must be 0, and this matrix of fxx, fyy, fxy, fyx must be greater than 0. Okay? Those are the necessary conditions for f of two different variables to have an extremum, which means either a maxima or a minimum. Okay? So when you're looking at one variable optimization, you only have one equation, fx equals to 0. Here you have two unknowns. So how many equations do you need?
Two.
Two equations. So these are the two equations. But these equations will give you some solutions. After you get those solutions, you have to still check whether those solutions represent a maxima or a minima or neither. Okay? Shh. So therefore, you have to first compute this. So this is, you first solve these equations. Equation 1, equation 2, you solve these to get the solution x comma y. And then you check if this condition is not satisfied, that means you are not at a maxima or a minima. If this condition is satisfied, then you are at a maxima or minima, and which one it is, you just look at fxx. So fxx is negative, then what is it? It's the max, and fxx greater than 0, it's nil. Right? Make sense?
Did the same apply for FYY as well?
Sorry?
The same apply for FYY?
I mean, you could check this with either one.
Oh, you're just saying you just need to check.
You need to check with either fxx or ffy.
Yeah.
You could check with either.
Okay.
Or
Given that that determinant may
exactly. Once the determinant is greater than 0, you know that they both will have the same sign. So you can do it with either one. Okay? Alright, so let's do an example. So I'll do one example in which there is indeed a maxima, and one in which case it's not. And then So the first example I will take is simply a mathematical example. I'll just say f, let's say is, so let's think of a sphere. So let's think of a sphere. Okay. So it's a sphere in 3D, so we know that x squared plus y squared plus d squared equals to, let's say, 1. Let's say that's the radius. So this is a sphere centered on x comma y comma z equals to 0. So let's define our f as d squared. So let's define it as 1 minus x squared minus y squared. Okay, so we are defining our f to be simply z squared. Okay? Because f is a function of x comma y, I can define it whichever way I want. Okay? Yeah, so far so good, everybody's happy? Alright, so now, let's check out, so our goal is to figure out the extremum values of this function f. So we just take fx to be 0, fx, in this case is?
Negative 2x.
Negative 2x, right? Okay, if that is 0, what do you get for x?
0.
Therefore x is 0. Okay, we also want fy to be 0, which is minus 2y equals to 0, so this will give you y equals to 0. So it tells you that our extremum lies at 0, 0. Okay? Now you have to figure out if that's a maximum or a minimum or neither. So we calculate this derivative, fxx, fyy, fxy, fyx. So this will be, what is fxx?
Negative 2.
Negative 2. What is fxy?
0.
0. What is fyx? 0. What is fxx?
Negative 2.
So you can see this equals to 4, which obviously is greater than 0. What does that mean? That means 0, 0 is an extremum, right? We still don't know if it's a maximum or a minimum. Well, actually, we kind of do know.
So if it fails, then
And we'll do an example of that, right? So if it fails, it's neither a maximum nor a minimum. What is it? We'll talk about that in a minute. So fxx you already see is greater than 0. Oh, sorry, less than 0. So what does it mean? Is it a minimum or a maximum? It's a maximum, right? And we know that space because that x equals to 0, y equals to 0, which is this point, right? You know that there is a maxima here, right? It's a tip. Does it make sense to everybody? Yeah? Any doubts? Yeah.
Since this is z squared, why doesn't it show us the minimum as well?
Because we are squaring it up, right? So the minus and negative. So basically z squared, once you take only the z squared, you're looking at only the positive half. And remember, what we are plotting is z. This is what you're plotting is actually z. But if z squared is a maximum, z also is a maximum, right?
Right.
But
So how would we modify this to show the minimum as well?
or you could basically do, if you take fx to be z, you get this, right? Sorry?
We have two branches now.
Then you have two values, yeah, depending on which ones you take.
what happens
Okay?
if
Because you'll get at x equals to 0, 0, 0, get a square root of 1 depending on if you take whether plus or minus.
What if
we can
you-
actually do it, yeah.
what if you can't get rid of like x on the z side?
Sorry?
What if instead of like z squared would be like e to the zx, and you can't get x's on the right side?
Well, f is a function of, no, I'm using this definition only to kind of facilitate drawing it. You can make fx comma y be anything. But if you start with x, y, and z, you cannot convert every function to an explicit representation. Right? So yeah, fx comma y could be anything. Alright, good. Everybody's happy? Of course, this was a very easy example. So now let's do another example. In this case, I'm not going to draw it, what it looks like. I'm just going to write down the expression, and then we'll talk about what it is. I actually will not be able to draw it very well, because I'm not very good at drawing. So let's just do the function f is x squared minus y squared. Okay. So what is fx? Still 2x equals to 0, means x equals to 0. What is fy? Minus 2y equals to 0, that means y equals to 5. So you can see the solution still is the same, 0, comma 0. But this determinant fxx, fyy, fxy, fyx, this equals to, what is fxx?
2,
2, fxy,
0,
0, 0, fyy.
-2,
This equals to
-4.
negative 4. So this is what, yeah.
Oh, no, go ahead.
So what is this? Is it a maximum or minimum? It's, huh?
Neither.
Neither. Right? It's neither because the determinant is already negative. If it's negative, you can't do anything. That's it, you're done. That solution represents neither maximum nor minimum. What is it? What, can you tell me what the shape is?
Saddle point.
It's a saddle point. Now, what does saddle point mean? Saddle point means that the location, the point you are at, it is, so if you think of a three-dimensional shape, right, which is what these shapes are, where f represents the height, x comma y represents the base, you can always essentially cut that three-dimensional shape by various planes. And if you have a three-dimensional shape and you basically cut a plane through it, what will be the projection of the shape on the plane? It'll be a
curve.
It'll be a curve. It'll be a two-dimensional curve, right? So the saddle point means that at least in one direction that curve will have a maximum at that location, and another direction will have a minimum. So let's say, for example, think of a saddle, right? As I said, I'm not even going to try to draw it because I am really bad at drawing. But I think I will try to invoke your creativity or your imagination. So imagine you're sitting in a saddle on a horse. If you think of and cut a plane through the center of the horse, that sounds weird. Okay.
Draw it.